Hello everybody, this is Zareian from Power Electrical Developing Advanced Research Group. In this short training video, I'm gonna talk about simulation and implementing power flow in power transmission system in presence of vehicle to grid. Actually, in this video, I will talk about modeling a vehicle to grid parking lot. Also, I will talk about power flow in power transmission system considering vehicle to grid. Before I want to talk simulation of this topic, I would like to talk about mathematical problem formulation of this topic using the following paper. As you can see in this paper, I will talk about mathematical problem formulation for power flow modeling considering voltage source converter based plug-in electrical vehicle. If you look at the mathematical problem formulation for this paper, you can see this paper uses the VSC based PEV for consideration of parking lot where the parking lot of vehicle to grid is connected to the main upstream power network. For example, the mathematical problem formulation for this power flow equations, it starts from equation number 6 to equation number 12. So you can see all of the details of a mathematical problem formulation by starting from the equation number 1, where the equation number 1 try to make a bus of the connected vehicle to grid to the main upstream network by a VSC model. So the PEV battery system is connected to the main upstream network by consider the connection bus, use a VSC model, and the power flow equation consider the VSC bus as a PV bus during of the power flow equation, where the power flow equation is start by the equation number 2 up to the equation number 12. But the main problem formulation is equation number 9 to equation number 12, where the equation number 9 try to model of the battery pack as a EV charge when the vehicles start to charge, and consider all of the PEV in charge mode as a demand. Also, according to the equation number 11 and number 12, consider the PEV when the PEV start to the charge mode, and consider all of these equations as consider all of the electrical vehicle lot as a demand in the system. So the electrical vehicle parking lot consider in charge mode as a demand, and consider as a discharge mode as a electrical vehicle source inverter based converter. For example, you can see all of these equations, and you can review all of these detail by start from equation 2 up to equation number 12 for all of the detail which is discussed in here. Also, you can see the figure number 3 for aggregation of each vehicle which is connected to other to the distribution system and can be connected to the bus number 15, where this bus is connected to the upstream network. For example, bus number 14 in this case study. In order to run the simulation of this paper, you can see the mathematical problem formulation which is simulated here. For example, this is the simulation file for this paper. By click on the link address and copy this address into your Matlab software, you can see all of the details related to the simulation. By press the key enter, you can call all of the simulation file which is provided for you in the Matlab software. This simulation consider IEEE 9 bus as a case study for this simulation. By click on IEEE 9 bus, you can see all of the details related to this paper, where this paper simulate their power system power flow as a case study for IEEE 9 bus. You can set all of your simulation model. You can change the bus data and line data according to your desired case study. You can run this simulation for all type of the case study. For example, you can use this simulation code for different type of IEEE standard bus. For example, IEEE 15, IEEE 39, and another type of case study that you want to use for your project. If you look at this paper, the bus data and line data is considered as the input data for this system. You can set the bus data in the matrix of bus data, and you can set the line data for your desired network if you want to simulate them in your project. Also, this simulation file consider 24 hours of a day and try to compare all of the parameters of the system when the power flow consider the vehicle to grid, also without consideration of the vehicle to grid effect on power system for different location of the system. For example, there are two loop for consideration when the bus location is changed from bus number 1 to bus number 9 in this system. Also try to calculate the different parameters of the system. For example, voltage deviation and loss duration of in 24 hours of a day. For example, this part is defined the V2G information for this system. V2G num is the matrix that show the probability of presence of the vehicle to grid in each parking lot. Also, maximum output power and number of the row for the series electrical vehicle and number of the column in the series electrical vehicle by variable n and variable number m that you can see in the paper. For example, number of series and number of the parallels for each vehicle to grid. Also, another parameters such as Tmax, Ts, Td, and alpha as a different parameters which is discussed in the paper here, and you can see these parameters for the formulation in equation number 12. Also, as you can see, another parameters of the system, for example, resistance and impedance of the inductance of the VSC, where the VSC bus is connected to the main upstream network, and a vehicle to grid bus is defined here based a bus data which is defined in the main bus data. After calculate the PEV in demand mode and PEV in supply mode, these parameters is located to the matrix in the matrix of the vehicle to grid data here, and this matrix is add to the main bus data, and line data is updated by this information when V2G line data. So we can use the V2G data for bus data and V2G line data and extend the bus data and line data main matrix by this matrix and add to this main bus data matrix and line data matrix. After that, in this main loop, the parameters of the system is a start and vehicle to grid. Power flow is a start by consideration of the vehicle to grid. After finishing the study of 24 hours of a day, different parameters of losses and voltage deviation is calculated for different for 20 hours of a 24 hours of a day. For example, if you run this simulation, you can see the simulation result for voltage deviation and losses during of 20 hours of a day. As you can see at figure number 1, you can see the curve of the loss for each bus of the system. In this study, we have different bus, and you can see before and after losses for 20 hours of a day. As you can see here, we have 9 curve for 9 bus. For each bus and for each curve, you can see the losses after and before the consideration of the vehicle to grid during the power flow. As you can see, in all of the system, vehicle to grid try to manage the losses in power system, because vehicle to grid try to inject power into system and reduce the losses during the power flow equation. And at each bus, you can see the condition of the losses at each bus. For example, bus number 1, bus number 2, up to the number 9. So for each bus, you can see the affection of the vehicle to grid, which is connected to the each bus during of 20 hours of a day for active and reactive losses. Also, you can see the same simulation for the voltage deviation during of the 20 hours of a day and total voltage deviation at each bus in 24 hours of a day. So we have a compare curve that you can use for your project for a study of affection of vehicle to grid parking lot, which is modeled by VSC into power system, and you can use this simulation for your desired project during of your research, during of your academic research. If you want to download all of this simulation file, you can go to our channel, our Matlab channel, and download the simulation of the mathematical problem simulation in our channel and use in your project according to your desired model. Hope this simulation and this training video will be useful for your project, and I hope I will see all of you in next training simulation. Bye for now.